we were looking at the projectiles, and projectiles on inclined plane was the topic we were discussing in the previous session. To continue that, we'll solve a few more problems. The first problem. Find the time of light and the range. Right. So a projectile motion has been given like this. This is the point P, this is O, this is 20 root 2 meter per second. This angle is 37 degrees. This angle is 45 degrees. Right, so this is the given projectile motion along the inclined plane, which is up the plane, and we have to find out the time of light, time taken to reach the point P from O along the projectile path, and the distance OP. Okay, so actually we can construct the triangle over here, which is a right angle triangle. We can use this if required. So this is 90 degrees. All right. Okay, so this is the given data, and for this data we can first find out the velocity along x-axis. That is, I want to find ux, right? Ux is actually, it's u is given as 20 root 2 into, say, this is the x-axis actually for us. So 20 root 2 cos 45. Cos 45 is 1 by root 2, so root 2 will cancel. This is 20 root 2 into 1 by root 2, this cancelled. So the answer is 20 meters per second along x-axis. Also, I can find what is uy required, that is 20 root 2 into sine 45. Okay, so the sine 45 is also the same thing. So 20 into root 2 into 1 by root 2. Sine 45 is 1 by root 2. So you have 20 meter per second as the answer. Okay. Now, since the horizontal distance is being considered over here, right? Particle strikes the point P, right, after t seconds. Okay, so if it hits the point P at after t seconds, right, I am able to find the horizontal displacement, that is OQ, right? I can try to find the OQ, which is equal to the distance OQ is measured, right? If you use the ux, that is a horizontal velocity, I am able to find out after time t seconds, it's going to reach the it's going to cover the distance OQ along the x-axis. Though the object is moving along OP, right? Because of the horizontal component of velocity ux, I am able to find the distance OQ. So OQ is equal to ux into time t, right? So what is ux into time t? Ux is 20, so this is 20t is the distance, that is OQ, right? I can write this is equal to OQ. At the same time, what is the vertical displacement? Vertical displacement, it actually covers a distance of PQ, right? From O, after time t, it will be at a height of PQ. So vertical distance PQ can be measured using Uy into T. Okay, right. But the vertical displacement is not simply that much. So vertical displacement is PQ is equal to, I have to apply ut plus half gt square, right? So let's assume that g is equal to 10. Okay, g is equal to 10 meter per second square. Let's assume g like this. Okay, so PQ is equal to my equation. This is the displacement along y-axis, right? Uy into t and downwards force of minus half of gt square. So that means uy is 20t minus half into 10 into t square. So this cancels as 5. So the PQ can be written as the 20t minus 5t square, right? Assuming that t is the time taken. Okay, now you use the equation to find out the time first. So if I know the time, I can actually find out, right, the any distance I want. Okay, so that means let's try to write. Therefore, this implies I use from the triangle, that is OPQ, I'm able to write what is tan. So tan of 37 degrees is equal to opposite divided by adjacent. Opposite is PQ and adjacent is OQ. Okay, so PQ by this. So PQ is simply written as 20t minus, this is 5t square. Okay, divide by, this is 20t. Right, so now we need to solve this. So let me calculate the tan 37 now. So tan 37 degrees is 0.7536. 0.7536 is equal to 20t minus 5t square divided by 20t. So I can try to write this as, let's multiply, cross multiply. So 0.7536 into 20t is equal to 20t minus 5t square. Okay, so this means 1.5, 15. This is 15t. So let's take the minus pi t square to other side. This is 20t minus 15t is equal to 5t square. So 5t is equal to 5t square. One of the t will cancel, 5 and 5 will cancel, so t becomes equal to 1 second. Right? So the time of flight is 1 second. Okay, once I have the time of flight given as 1 second, right, I can try to find out the OP now. OP is equal to, what is the equation for OP? So OP is equal to, this is, right, I can relate using the OQ, right? So that is a cos function. So cos 37, right, I'm going to use this equation. Cos 37 is equal to, this is OQ divided by OP. Okay, so OP is equal to OQ divided by cos 37. But OQ is nothing but that is a 20t. Correct? So this is 20t divided by cos 37. I need to calculate this at t equal to 1 because the time of flight is 1 second. So this OP is 20 divided by cos of 37 comes to be 0.7986. This is 25 meters. So the distance that it covers is equal to 25 meters. All right. All right. Let's move to the next question. Question remains same. This is find the time of light and the range. Horizontal. Okay, so this is 30.34 meter per second. This is 60 degrees. This is 30 degrees. So we can give the same names, like this is O, this is P, and if you draw vertical, you can call this is Q. Okay, take G is equal to now 9.8 meter per second square and solve this question. 1 second. So the time of flight t is equal to 3.57 seconds, and the range that is OP is equal to OP is equal to 17.51 meters. All right. Okay. Another question of the projectile motion under this condition. Let's see. Question remains still same. Find the range and the time of flight. So this is 20 root 2 meter per second. If I draw a horizontal axis, then that angle is 45 degrees. And this inclination is given as 37 degrees. Okay, so let us assume that this is O, this is the where it touches ground is P. All right, under this condition, our intention is now to calculate the time taken along this path OP and the distance OP along the line. Okay, so this is what is asked. Okay, all right, so we'll start very similar to the previous problems, but now we need to complete the triangle for us to simplify. Let me draw a triangle like this. This is going to help us. So this angle is also going to be 37, and let me call this as say Q, where I have 90 degree. I create a right angle triangle for us. Okay, so now let us assume that the moment is along, these are the x and y axis. So for me, this is positive x, this is positive y. Okay, so let's write the ux like always. So ux is equal to the u, that is 20 root 2 into cos 45. So cos 45 is 1 by root 2, so that gives 20 meters per second as the answer. Similarly, I know now that the even uy is 20 root 2 into sine 45. That comes 20 meters per second. Okay, now if I want to calculate the horizontal distance QP, right, then that will be using the ux into time, right? Because there is no a along x-axis. Normal equation, distance is equal to ut plus half ut square, but ax is equal to 0. All right, let's take the g as 10 meters per second square for this problem. All right, so this means if I want to calculate PQ, this distance has to be ux into time, so that is 20t. Okay, at the same time, if I want to calculate this OQ, that is the distance covered along y-axis. So I'll write OQ is equal to I have to use the displacement is downwards, right? So since I'm moving downwards now, right, I have to write the reverse of my equation. So I'll get normally after simplification 5t square minus 20t. Okay, so we use this now. So using this is the equation number 2. So apply these two to calculate the tan of 37. So tan 37 should be equal to OQ divided by QP. So tan 37 can be approximated to 3 by 4.75 should be equal to the OQ is 5t square minus 20t divided by 20t. All right, let's solve for t now. So that is 3 into 20, 60t is equal to 20t square minus 80t. Okay, so 80 plus 60, that is 140t is equal to 20t square. One of the t will cancel. 20 cancels this as 7. So time t is equal to 7 seconds. So the time of flight now becomes 7 seconds. All right, now our intention is to calculate the OP, which is the range. So this implies OP is equal to, I just have to use the PQ divided by cos 37, right? This has to be substituted at t equal to 7 seconds, right? With the t equal to 7, right? So PQ is a 20t, so that is 20 multiplied by 7 divided by cos of 37, that is 4 by 5. Approximately this comes to be 175 meters. Okay, right. This is another practice problem for the similar problem. This angle is 35 degrees. and this angle is 40 degrees, and the initial velocity is 48.36 meters per second. Okay, so this is O, the point where it touches is P. Still we can draw a right angle triangle. So even this becomes 40 degrees. This is what we call as Q. All right. So take the G value as 9.8 meters per second square to find out the following. Okay, we want the range. First, you can calculate the time of flight, and then you give the distance OP. The time T is equal to 12.33 seconds. All right, and OP 630.5 meters. All right. Okay, that looks pretty much closer to the required answer.